for the last talk of today, we have Mahmoud, who is a colleague of mine. He also works in the DevRel team here at Prisma. He is a developer, a writer, a maker, and obsessed with creating exceptional high-quality content and applications. I can vouch for the high-quality content. I've seen his videos and I love them. So without further ado, I would like to bring Mahmoud to the stage. Yes. Hi, Mahmoud.
Hey, thanks for the intro. How's it going?
It's going well. Are you ready for your talk?
No, kind of like this is, I think, this is like my first time ever talking at a meetup remotely in English. I've done it before in Arabic. You can hear me and see me clearly, right? Like I'm not frozen. Everything looks great, right?
Yes, everything is perfect. I like the backdrop, by the way. Yeah.
Oh yeah,
Maybe we can
thanks.
give up some tips on that. So
Very professional.
yes.
And yeah,
So
before starting, I would like to say I encourage everyone to apply to speak at Connect Dev Meetup. It's a fun experience. And if you feel like, oh my God, I have nothing to talk about, I have nothing to share, you can share anything, something you've learned, your journey, an experience. And yeah, like right now, I'm currently working on a course with Prisma. It's going to be like full stack. It's going to be big. It discusses like GraphQL with Next.js and TypeScript and Prisma. So stay tuned for that. Make sure that you subscribe. And yeah, so like this talk is kind of me experimenting with how I would explain GraphQL. So yeah, I can start right now.
can't wait. Whenever you're ready to share your screen.
Oh yeah. Wait, I will need to share. So this screen, you should be able. Oh, I can see myself. Nice. Oh yeah, I'm supposed to start. Okay, so welcome everyone to this talk. The talk title is The Beginner's Guide to GraphQL. My goal of this talk is to just give you a general understanding of what GraphQL is, why it's awesome. So if you don't know what GraphQL is, this talk is for you. If you already know what it is, most likely you'll know what I'm about to tell you. But still, it can be like a nice refresher. So sit back, relax, grab your favorite drink, because we're about to learn some GraphQL. Before starting, though, hi, my name is Mahmoud. I work as a developer advocate at Prisma. I'm also an instructor at Egghead, and I recently became a community builder at AWS. You can find me. I'm most active on Twitter, so yeah, feel free to DM me. Let's talk. And these are my other links, so like my GitHub and my website. So yeah, building APIs the traditional way. So when we think about building APIs, I'm assuming you've already worked with APIs. So either as a front-end developer, you consumed a REST API before, or if you're a back-end developer and you built REST APIs before. So you have your client and you have your server and your database. So what happens is there's a request and response cycle going from the front end to the back end, and it just continues. So the client sends a request to one of the many endpoints of a REST API. The server responds by talking to the database and then returning the data to the client. So yeah, this is an example of a REST API. So if we go back to talk to the server, like from the server to the database, there are many ways. You can use the database's native querying language. So for example, if you're working with a SQL database, you would use SQL. But I personally like to use Prisma. So Prisma is an ORM, so it makes it easy to work with databases. So this is an Express app. What I'm doing is just I'm importing Prisma and like instantiating Prisma client and creating a new Express app. So this is just a single endpoint. It's a /users. It responds to GET requests. So when I go to this endpoint, what will happen is I'll just return all the users in my database. So this is just like to establish kind of like the foundation. So yeah. So REST APIs, they actually do have some good parts, and that's why they became popular in the last couple of years. So the first thing is they're flexible. So when I wrote the code for this endpoint, an endpoint can handle many types of requests. So for example, I have an endpoint where I want to update a certain item. It can be like a user, a post, whatever. So this endpoint can be like, I don't know, /user/ID. It can handle both an update or a delete. So it's very flexible. And then they're cacheable. So if there's a certain endpoint that is being heavily requested, you can easily cache it. It's just a single endpoint. And then finally, there's a separation between like the client and the server. So you don't know, there's no tight coupling between the two. A client doesn't need to know what happens behind the scenes in the server. All you need to do is just know what endpoint to talk to, and then the endpoint responds. But so yeah, so to like with everything in tech, like there's no perfect tech. Everything has its own pros and cons. So there are some drawbacks to REST APIs, and I would like to show you these drawbacks through an example. So let's assume that we're building a clone of dev.to. Gift mentioned it, like the Practical Dev is a blogging platform for those of you who don't know, but most likely you already know. So you have posts, you have users. A user can create posts. Post has comments, has likes, and yeah, and it also has tags. So it's like Medium if you haven't heard of dev.to. So how would I design a REST API for dev.to? So there are multiple endpoints that we're going to need. So the first one is an endpoint to return all users. Maybe I have like a dashboard and I want to see all users of my app, of my website. And I would need another endpoint to return an individual user, because say, for example, I want to view this user's stuff only. I don't want to kind of like just load the entire data from a single endpoint, because then it would take a long time. And I would also need an endpoint to return this user's posts. This is like a design decision, because maybe there are many, many posts. So I want to have an endpoint that just returns the post for a certain user. And the same thing for the followers, and the same thing for likes. And I want an endpoint that returns a feed. So like on the homepage, I can see a list of posts. And then I want to return a single post. So when someone views my article, I will just send a request to this endpoint and it will return the article. So this is like the profile page that I want to build. So as you can see, there is like my profile. You can see my name, my bio, when I joined, some links, where I work, my education, and some badges. So it makes sense to add this data in a single endpoint. And when I want to make a request, I'll just make a request to this endpoint and the data is returned and I can display it. But what if I want to load the most recent post? Okay, that's cool. Like if I were a backend developer, I'll just include it in the API response. I will just get the user's posts and just send the latest one. But what if I want to also display the recent comments made by a user? So now it doesn't make sense to have this data in a single endpoint. So what do I need to do? I will need to create another endpoint. So, okay, fine. So I have multiple endpoints. What's the issue? Well, when you have multiple endpoints, you often have two issues that I'll explain in a bit. One is called overfetching and one is called underfetching. But anyway, let's assume that everything works, everything is nice. There's one major issue. So every REST API is different. So I, for example, designed my API in a way where I have a separate endpoint for followers and an endpoint for likes. Someone else might have said, okay, no, why would you separate them? That doesn't make sense. Why not just have a single endpoint to return this information? Or why not include it in the profile? So my notifications. Okay, so there's a learning curve when adopting a new API. This is like, okay, so when I'm learning a new API, there's going to be some time until I can actually be productive. I need to understand the different endpoints, what type of responses, the type of parameters they take. So yeah, that's kind of a drawback, but okay. So this is like a big pain, in my opinion. So you need to maintain up-to-date documentation. So you have a front-end team and you have a back-end team. The back-end team is building the API, and they created different endpoints. Each endpoint has to take certain like you have to know the response, you have to know the arguments. You also kind of just need to go through a lot of documentation, and this needing to maintain documentation slows you down. So to me, these are kind of like, this is an issue with REST APIs. So the nature of having many endpoints makes maintenance hard. So overfetching. So what is overfetching is when you have an endpoint that returns extra unnecessary data. So say, for example, in the profile page that I was talking about, what if the backend engineer said, okay, I'll just return the recent comments, but like in the UI, I'm not really using it. So what's happening is I'm actually using data that I'm not using. So like, okay, this is just wasted like bandwidth and also made the API response slower. And on the other hand, you have underfetching. So what to me, this kind of like hurts a little bit. So like when I'm working and I see that, okay, there's a REST API endpoint and there's like extra data, that's fine, like extra data. But when I find myself needing to actually make another request to another endpoint, I feel a little bit of pain like on the inside. So an example is you have to make a request to an endpoint. This endpoint returns a response. You have to make another request to another endpoint, and you need to combine these two in your UI. So this is not optimal. Why? Because you would have to wait for all of these to finish. So yeah, like managing, like talking to multiple endpoints and like combining data on the front end is just a lot of work, and it's not the best developer experience. And then finally, REST APIs are not typed. So when I defined the endpoint that returns all users, well, say for example, I have another endpoint that creates a new post or does something, I have to make sure that the correct types are passed. Otherwise, I can have unexpected behavior. So say for example, I'm a front-end developer and I know that, oh yeah, IDs, they should be strings. But on the back end, they're actually like a number. So like it's not just IDs. Say for example, I don't know, a currency or something that should be a number. I was like, okay, yeah, of course it's a number. And instead of like checking the documentation, I just assume. So whenever you make assumptions, most likely there will be errors and problems. So types solve that issue. But REST APIs do not have types built in. So yeah, you can have unexpected behaviors on the front end, on the back end. So say, for example, you in your logic, you're kind of working as if you're working with an int. So the solution is to add like validation, but it's just a lot of work that could have been skipped if we use types, but REST APIs do not have that. And oh yeah, so this leads to frustration. I added this GIF before like the actual talk. I did not have it. Okay, so GraphQL, the better REST. Now, if you remember the first diagram, you had different endpoints like coming in the REST API, and you have like again to the server. So you have multiple endpoints, but with GraphQL, it's different. You have a single endpoint that you talk to, and what happens is you ask for the data you want, and the data you want gets returned. So to me, this is like mind blowing because when you think about it, yeah, it is just incredible because now there's no underfetching, there's no overfetching, and you talk to a single endpoint. And the beauty of GraphQL is, you'll see in a bit, is that also kind of like generates the documentation for you. So like it's just instant productivity boost. And yeah, so this is what I mean by like this is an example of a GraphQL query. You just here I'm asking for like in the example of dev.to, I'm asking for like all posts, but I just want the title. I don't want like the author. I don't want the content. I just want the title. And here I see that it's returned just the title. And the response, it is again in the same shape of my request. So like, okay, this is really interesting. So how does it all work? How our GraphQL APIs are built? So we saw in the beginning of the talk that how you would build a REST API, you would define an endpoint, you define like the request type, and then you write like in the function how you handle like the logic that will be handled when the request is sent to that endpoint. So in the example, we created a GET request at /users, and we use Prisma to fetch data from the database and return it to us. So yeah, let's see how we can actually do this in GraphQL. So it all starts with the GraphQL schema. This is a file where you define all operations that your API can do. So like this includes input arguments and possible responses. So we will see like in depth each component of a GraphQL schema, but think of a GraphQL schema as like the contract between your client and your server. So you have a single source of truth where both can contribute to, and you can easily like track changes and see, okay, what is happening. And the beauty of having a GraphQL schema is when you look at it, you understand like you kind of get like a high level overview of how the API works. So the different relationships and like the different functions or different queries and mutations. We'll also go over what these actually mean. So it just starts with a GraphQL schema. This is like the QL in GraphQL. It's like a query language. So I think of GraphQL as a like a language for your APIs. So like this way, the client and the backend can actually communicate with each other. Because when you see with REST API, you're just sending a request and you're getting a response. But like you're not really like there's no common language that the two can talk to each other with. So now object types. So object types represent a kind of object you can fetch from your service and the fields that it has. So in the example of dev.to, I will have an object type of post. Now a post, I will specify the different fields that it has and its types. So I can say a post has an author and it has a title, and each one of these are of type string, excuse me. So of course, this is incomplete because I would have things like maybe a number of likes, I would have a number of replies, and yeah, and say for example, I would also need instead of a post, I would also need like an object type of like a comment, and I can say that a post will have many comments, and yeah, so like as you can see here, I'm describing like my system. So these kind of like are the most basic component of a GraphQL API in a GraphQL schema. So the object type. So for example, in the example of Twitter, you would have a tweet, or in a YouTube video, you would have a video, etc., etc. And then you have queries. So queries are, think of them are object types, but they're like an entry point to the GraphQL API. So anything inside this query type, think it as a function. So here I have a field called all posts that returns an array of type post. And then I see like the exclamation mark. This means that whenever I send the all posts query, I must get a response. This means like this is not nullable. I must have something returned. It cannot be null. So the way I like to think of it is that, okay, this, when I look at this mini or a micro schema, I see that I have a query. It's called all posts, and it will return all posts for me. And whenever I send this query to my GraphQL API, data will be returned. And then you have mutations. So these are operations related to mutating or changing data. So if we're going to think with the REST API mental model, you have like the post, put, and delete requests. And actually for the query, it's think of it as a get request. So that's how they decided to kind of like separate it, one for querying and one for like just changing data. So this is like, okay, so say I want to create, read, or no, I want to create, update, or delete something in my app, I will create a mutation. So here I have a mutation called comment, and it takes like the post ID, and the type of the post ID is a string. And actually, this has an issue because I did not say that the post has an ID, but I should have done that. But yeah, so this is just for you to kind of like wrap your head around GraphQL and how it all works. So yeah, these are the building blocks of a GraphQL API. But you might be wondering, okay, is this it? Where is the part where I actually define the logic? So like in the REST API example, what happened was, okay, we use Prisma to talk to the database. Where are we doing that here? So here comes the final part, resolvers. So resolvers are the functions that will be executed once a query or a mutation are called. So say, for example, in all posts, I need to define a resolver for this query that uses Prisma, that uses another ORM, that sends a SQL query, and then the data is returned. So you define in this function what should happen when a query or a mutation executes. So here's an example of a GraphQL server using like Apollo server. Apollo server is a library used to build GraphQL servers. So it is the server layer in like the stack that we had where you have a client and a server. So looking at the code, hopefully you can see it and it's not too small. Here I'm just importing Apollo server, and I have type defs. Type defs here I'm defining, basically this is the schema. And then I have resolvers. It's an object. And inside it, I have a query. And inside the query, I have posts. So I'm here naming it posts because at the top, it's like the query is also called posts. So they should be in sync, like the type definitions and the resolvers, they should have the same name. So that it works correctly. So in this query, I'm just saying, okay, here's a function that returns an array of 2 items, title and author. And then what I'm doing is I'm creating a new instance of Apollo server, and I'm passing the schema and the resolvers. And with these two combined, you have a GraphQL API. And then finally is just server.listen. This is just to start the server, and it will be ready at a certain URL when we call this function. So yeah, this is kind of like the hello world of GraphQL. And yeah, this is kind of like on the back end. And if you're a backend developer and you're building a GraphQL API, this is kind of done. But on the front end, though, you can use GraphQL clients. Now, it's not necessary. You can actually send a query to a GraphQL endpoint in like just good old fashioned way, like kind of like the same way you would talk to a REST API. But if you do it this way, you're missing out on a ton of awesome features of GraphQL. So a GraphQL client gives you some amazing features. So things like pagination, caching, and updating your UI is kind of like given for you for free when you're using GraphQL. So say, for example, I don't know, I have existing data and a query happens in the background. I will see that, okay, my UI updates accordingly. So yeah, so some more resources for you to learn about GraphQL, because I kind of just scratched the surface. Like my goal is just to make you excited about it, make you want to learn more about it. So yeah, you should check out graphql.org. This is the official GraphQL website. They explain with more examples, a lot more in depth. And you also have howtographql.com. And yeah, my upcoming course, it will be live on Prisma's YouTube channel. There will be like a big practical example, so make sure that you check it out. And yeah, turn on notifications so that you do not miss it. And that's it for me. So thank you so much.
Really awesome talk, Mahmoud. I enjoyed that.
Yeah, like you already know GraphQL. Go on.
Well, I do have one question, despite knowing GraphQL, is that since we do have an issue of awareness of types on the backend and front end, how can I, as while I'm fetching the data, how can I know the types that I should expect from an API while building a front end?
Okay, so there's actually a tool that I kind of I showed very briefly when I showed an example of a GraphQL query. This is GraphQL Playground, and it's kind of like basically a place where you can explore a GraphQL API. It shows you documentation, it shows you the different inputs, and yeah, you can just see it and work with it. And combined with like something like TypeScript, and actually GraphQL, if you send the wrong type, you will get an error, I believe. So yeah, like you get amazing developer experience. You can iterate faster because you can just ask for the data that you want. You just, if say for example, I'm a front developer and there's a requirement that I need, I'll just say, can you just create this query for me, and they'll just create it. No need to maintain like different versions of documentations. If you want an example of like a massive API, check out like GitHub's REST API. So like you'll find multiple versions. It's just long. With GraphQL, you can just be very productive. And yeah.
All right, awesome. Let's see if we have some comments or questions in the chat. I think Joey has highlighted that we can use a tool called GraphQL. I think it should be CodeGen to generate.
Yeah, so to generate types. Yeah, so yeah, it also generates types, and I believe the like your resolvers. So you would just need to define a GraphQL schema, and everything would just magically be like created for you. So like it's amazing. It's an amazing tool. Yeah, that's true.
I wish I could do the magic, Yeah, just GraphQL really feels like magic.
Yeah, I agree. Oh no, I froze. Did I freeze? Is it you? Is it me? No. I really hope it's you. I'll feel bad if it's me. Should I join and rejoin? Was it Alex? Was it me?
That was Alex. Okay, Alex is back. I wanted to take over here, but you're back, Alex. Alrighty. I'm scooting away.
Cool.
Nice.
Sorry about that minor glitch. Well, how else are we going to know that it's a live event? Yes. Did Mahmoud's video just pause? I cannot tell. So, thank you, Mahmoud, for the awesome presentation.
Okay, everything works. Okay, yeah, we're back. So I
Yeah.
kind of went away for a little bit. Yeah, you're welcome. And I highly encourage everyone to apply, come speak. It's fun. As you can see, like, I don't know, it's not as scary. I'd say the only thing you should be scared of if you have bad internet connection, at least that's me, like I'd be terrified because like I want to deliver kind of like the best experience for a talk. But otherwise, yeah, if you have a good internet connection, like just share your knowledge. Show us something cool you've built. And yeah, just I say reach out to Alex anywhere. Like he's everywhere, Twitter, LinkedIn. Yeah, and like he will set it up for you. So yeah.
Yes. Oh, we have one question in the chat. Is there a use case where you would not advise GraphQL, or use cases where REST API would be preferable?
Actually, yeah, I would say GraphQL needs some setup in the beginning. And if you have like a very simple app, it's not worth it to just build using GraphQL API. It's fine if you have a couple of REST API endpoints. And yeah, I would say GraphQL makes a lot of sense for kind of like medium to large scale projects where you have maybe possibly multiple people working on a project. But if it's just you and like you want to spin up something real quick, just use a REST API. If you're working with like Next.js, they give it to you out of the box. So yeah.
All right.
Or Next.
Awesome.
So like all frameworks are awesome.
Yes. All right. I think that will be all. Thank you again, Mahmoud, for your time. I really love the talk. Yes.
You're welcome. All right. Awesome.
Awesome.